Now we're going to wrap up on this discussion of Islam by taking a look at a few contributions that we normally associate with Islamic society and science and technology. Again, we've already laid a little bit of the groundwork to suggest that Baghdad, Toledo, Cordoba were some of the major places of study of contribution. And overall, we can see lots of different contributions. And again, McClellan and Dorn will go through some of the ones they think most significant. But here's just a quick overview of some of the things as we're moving from the ancient world into the medieval world, and from the medieval world into the early modern, that we see Islam sort of serving as a bridge. So again, contributions in mathematics. We'll talk a little bit about algebra, everybody's favorite math class. We'll talk a little bit about astronomy. The Muslims used their observations of the heavens not only for what we might call scientific inquiry, but also for helping them to set calendars and to regulate the proper times of day to pray, right? So astronomy for that. Medicine, again, just as we have seen contributions in other societies to medicine, the human condition is a frail one, and much of our connection to science and society relates to how to help people live well and help them to survive calamities of the body, of health. We'll also see the Muslims engaged in alchemy, which is sort of the magical side of chemistry. And typically in early societies where chemistry is just starting to get dabbled into, we'll see it tinged a bit with alchemy. Again, alchemy more of a, first off, it is an Arabic term, alchemy, but it's also a sort of idea of, can we change the properties of one metal to another? Can we change lead into gold? And how can we do that? So you can see that that's connected to chemistry, but also perhaps even connected to medicine in a way. Cosmology, very much connected to astronomy, but perhaps also connected to what's our place in the world, so a little more philosophical. Ophthalmology, the study of the eyes. Optics. Light. So for the first time, we're seeing some strides being made there. Geography and cartography. We've mentioned this already in our previous video on map making. So just to give you a couple of examples of some of the notable figures, and these I've taken just from an encyclopedic entry, so I don't claim ownership of them. Al-Battani, a very early astronomer around from 850 to 922, he could determine accurately the length of the solar year. So 365 day year. We're still fascinated by calendars, right? We talked about this from the early days. Every society seems to want to get that accurate calendar to predict nature, to try to predict the seasons for agricultural purposes, for purposes of predicting weather patterns, etc. So, but also they can connect as well, of course, to religious concerns, religious events in any calendar. Ibn Ishaq al-Kindi, he was a philosopher and scientist who translated Greek classics into Arabic. Right, so very important fellow associated with these various schools that have been set up. In Baghdad, there was the so-called House of Wisdom that McClellan and Dorn will talk about, and a place for people to just debate, discuss, right? So here we have that, and this particular fellow, Ishaq al-Kindi, was very important in that regard. He also worked to reconcile conflicts between the Islamic faith and his approach to reason. Right? The Greeks are not Muslim. You know this. The Greeks are not monotheistic. And he, like many Christian philosophers, will try to figure out, how do I reconcile what I see is very interesting in the mathematics of these polytheists, right? But how do I reconcile that they have access to scientific answers, if you will, but they don't know the one true faith, the one true God. So, so he is very important philosophically in that regard as well. We mentioned medicine as important in this. Ibn al-Nafis, moving into the Middle Ages, into the 1200s, was a physician born in Damascus. That's in ancient Syria, who practiced medicine in Cairo in Egypt. One of his works, discovered in 1924, offers a description of the circulation of blood from the right to the left ventricles of the heart through the lungs. So, starting to figure out the circulatory system of the human body in the 1200s AD, 1200s AD. So, really making some extraordinary developments in medicine. We know also, in addition to this fellow's work, that in the 1100s AD in Baghdad, that other Greek doctors were starting to figure out what we might call contagious diseases, things like measles, right? Starting to figure out how those diseases transfer from one person to another. So starting to work on what we might call epidemiology. And as I warned you before, algebra. This is an Arabic term, a fellow by the name of Al-Khwarizmi, and I'll say that wrong, I'm sure. He's considered the greatest mathematician of Islamic civilization. He was instrumental, as we've noted before, in the adoption of the Indian numbering system, later known as Arabic numerals. And so will be the Arabic culture that will spread this numbering system far and wide, but they will adopt it from Indian culture. So again, reminding us of those connections by trade, those connections between various cultures. And again, Baghdad right in the middle, right there in Mesopotamia. You remember the Fertile Crescent from the very first week. Right here, this conduit of culture between all these different cultures. So Al-Khwarizmi, he developed algebra. He was influenced by both Indian and Greek mathematicians. And just a few images here of some of the technological advances. The Muslims are very much interested in navigation by the stars, because that's how you get across the desert, because you typically want to travel the desert at night, and your landmarks, if you will, your points of reference will be in the heavens. It is easier to travel the desert by night than it is by day, and even if you're traveling in the day when the sun is out and it's much hotter, your landmarks may not stay put because you're in the desert. So it's easier, it's safer to travel by the stars. And so the astrolabe was a device, which we have an image of here, that allowed folks to find a fixed point on the horizon and then reconcile that with heavenly bodies to try to figure which direction they ought to be going in. So the astrolabe, very important not only for navigating across land, but eventually inspiring others to navigate across the seas. We had one of our great contributors work on optics and the eye, and so we've got one Muslim scholar here in his treatise on how to identify various parts of the eye to actually draw a picture of the eye. And so again, working on biology, working on medicine, working on human anatomy in Islamic medicine. And here a page from a treatise on mathematics, on algebra. We'll end this discussion on Islam with another image of sort of the philosophical school, the House of Wisdom. And in this image, you see down at the bottom, map making, a globe. You see different scholars writing, discussing, debating. You see different instruments up here. We're looking towards the heavens with another sort of measuring device, an astrolabe perhaps, or even something like a sextant. Here's an astrolabe here. Here's another example of an astrolabe. So we have all kinds of measuring devices, all kinds of discussions going on in this scholarly area. So again, this little video has been to give some examples of Islam and their contribution to the history of science and thought and science and technology. And just to remind you once again, because it can't be said often enough, the origins of Islam right here at the crossroads where East meets West, Baghdad, the city that's right here in the center that allows connections to India, to China, to ancient Greece. And then if you go over to Toledo into Spain, you'll find in the medieval period Christians, Jews, Muslims, all working together, asking similar questions, and a lot of their work survives well into the modern era. In fact, some of it we're still trying to understand and uncover. So ultimately, these scholars working on science, working on technology, are taking ancient Greek ideas, Indian ideas, Chinese ideas to some extent, trying to reconcile them with their monotheistic faith, preserving these ideas, passing on these ideas, and it's going to be these kinds of efforts, not only by Muslim scholars, but by others, that lead us to European traditions and European achievements in science. We'll get there next time. Thank you.